Today we are doing lesson 3.1, functions and relations. Now, we're beginning a new chapter, but also let me go ahead and say this not to freak you out, but to get you to focus. This is one of the toughest chapters that we are going to do, all right? Now, today's lesson is not meant to be tough, but if you allow yourself to zone in and out, then it's very possible that you will get lost. So please make sure you stay with me. Does anyone know what a function is? Does anybody remember ever learning what a function was? Well, that's good because the essential question today says, what is a function? So by the end of the lesson, you should be able to answer that question. Now we start with the word relation. A relation pairs an input with an output. Now I like to be practical if I can. So let's talk about a relationship. How many people are typically in a relationship? 2. Okay, so wouldn't the word relation make sense? It pairs inputs with outputs. So relations pair two things together, an input and an output. Now, a function says that for every one of those inputs, there is exactly one output. Now, you'll also notice next to the word input, I have in parentheses the word domain. By the end of this lesson, there are going to be 4 words that represent input, and there are going to be 4 different words that represent outputs. And by the end, we will have all 4 of those words in the same spot so that you can see what is interchangeable with what. But the first thing I want you to do, I want you to highlight input, domain, one, output, and range. Okay? So the input, also known as the domain, for every input, there can be exactly one output, also known as the range. Now we're going to keep this simple in example number 1. It says determine whether the relation is a function. So it's already telling us that the problem is a relation. We're trying to figure out if it's a function. Now let's talk about this for a second. Does it make sense that letter A is a relation? Does anybody recognize what we're looking at in letter A? We have all these little sets of parentheses with these numbers inside. Does anybody know what we're looking at? Ordered pairs. Very good. All right. So they have paired an input and an output. They've paired 2 things together. Also known as what coordinate and what coordinate? X and Y. So if you need to add that, if you have forgotten, ordered pairs are made up of an X coordinate and a Y coordinate. You can add that. All right. Now look at letter B. Anybody recognize what we're looking at on letter B? A chart. Okay. A little X and Y chart, a little input-output chart. So again, they're pairing 2 things together. So these are relations because they're pairing X coordinates and Y coordinates together. But they want us to determine if the relation we're looking at makes a function. So for every input, is there exactly one output? And this is how we're going to do that. I want you to add this note next to the directions. We're going to focus on X. If we focus on X, then we're going to be able to tell very, very quickly whether we are looking at a function or not. Now, if we wanted to make our lives complicated, we could draw a coordinate plane, we could plot these points, and then we could decide if it was a function or not. But why in the world would we want to waste our time doing that when we can simply look at the X coordinates? Now, who's brave enough to tell me what the X coordinates are? Okay, we got a -5, 0, 5, and 5. Okay, so we're focused. Listen, highlight them, draw an arrow to them, circle them. I don't care what you do, but make sure you know the focus is on the X values because that's where we want to focus. Now, are every single one of those X values different? Look at every single one of those X values. Are every single one of them different? No. If they were, we'd be done. This is a function and we'd move on. But as soon as we see one of our X values repeating, we have to stop and look at it a little bit closer. So when they put this first 5 in right here, what came out? A 0. And when they put this second 5 in, what came out? So for every input, is there exactly one output? No. So is this a function? Not a function. So final answer, not a function. But again, all we had to focus on was the X values. As soon as we saw there was an X value that repeated, we saw the outputs were different, we were done. It's not a function. Now go look at your chart. What are the X values on your chart? Highlight them. Circle them. Make them stand out. 2, 4, and 6. Are every single one of those different? Then do we have a function? Yes. We don't have to do anything else. As soon as we recognize every single x value is different, we know we have a function. Because for every input, there's only one output. And that would be an explanation. If I ever asked you to explain your answer, that's what you would tell me. You would tell me it's a function because every input has one output. What would your explanation be here? This is not a function because the input of 5 has 2 different outputs. Okay? But for every input, there can only be one output. Have I lost anyone yet? Now, we move to letter example 2. Determine whether the graph represents a function. So this time they've given us a graph and they want us to decide again if it's a function. Now, we could pull all the ordered pairs off of that circle graph and all the ordered pairs off that parabola and do exactly what we just did. But is there anybody who really has any interest in doing that much work? No. Awesome. I didn't think so. So we have something called a vertical line test. Now let's talk about vertical because this is important. Does a vertical line go up and down or right to left? Up and down. So we are going to perform a vertical line test on our graph. It says if a vertical line passes through a graph one time, and if you'd like to add the word exactly one time or only one time, that wouldn't be a bad idea. Okay, but if the vertical line passes through the graph one time, the equation is a function. Now you'll see when I draw my vertical line, I'm going to make it a dotted line because I don't want it to look like it was originally part of the problem. But you can go anywhere you want on this graph and you can draw a vertical line. So I'm going to draw a vertical line. I'm going to put my arrows on the end. And here's the question I ask. How many times does that vertical line pass through the graph, the circle? Just one? It passes here and it passes there. Now, is it a function? No, because look at the vertical line test. If a vertical line passes through the graph one time, just one time, then it's a function. And this vertical line passed through twice. So the answer is not a function. But that is it. That's the only work I have to see. I have to see where you performed the vertical line test, and then I have to see your answer. Now, what if someone chose to start their vertical line over here? Does it really matter? How many times does that vertical line go through the graph? Twice. So it doesn't matter where you draw your vertical line as long as you draw it somewhere on the graph and figure out how many times it passes through. Now let's look at letter B. This is called a parabola, and eventually we will be learning how to draw parabolas. But for now, we're just trying to decide, is it a function? So let's do our vertical line test. Again, anywhere you want. You can draw that vertical line anywhere you want. Put those arrows on the end. How many times does this vertical line pass through this graph? One time, all right? It only passes through one time. So is it a function? Yes. It is a function. So final answer, function. And you're finished. So the only work I require is that I can see your dotted vertical line so I know you performed the test. All right, example number 3. Now this is where it begins to get a little bit tricky. Okay, so stay with me. They want us to give the domain and they want us to give the range of the function. Now domain and range are words that are not going anywhere anytime soon. They're going to be with us for the rest of the year. All right, so you've got to learn now what the domain represents and what the range represents. And you can see I've given that to you in parentheses. So give the domain, also known as the input or the x values, and the range, also known as the output or the y values. So now we're up to 3 words apiece. 3 words for your input that are interchangeable, 3 words for your output that are interchangeable. They all mean the same thing. So in letter A, we're going to go ahead and write domain. And I do want you to do this in your notes. Go ahead and put the little x in parentheses. Again, we're just trying to learn domain and x values are the same thing. So we're going to put the x beside domain, and beside range, we're going to put a little y in parentheses. Don't necessarily have to do this on a quiz or a test. But again, for now, we're trying to learn that they go together. Now that means the domain is all of the x values from those ordered pairs. So let me just ask you this. How do you think I would like you to write that list? In what kind of order? like least to greatest, okay? Least to greatest. So I don't want you to just throw down all the x values however you want. I prefer them least to greatest. That'll make everything move quickly and smoothly. Now, I kind of helped you out on these ordered pairs because who can raise their hand and tell me what are the domain, or what is the domain? Cameron? 1, 2, 3, 4, and 5. Again, the x values, 1, 2, 3, 4, and 5. Now, the range are the y values. Jordan, what are my y values? Again, least to greatest.
-2, 1, 6, 13, and 22.
There you go. And again, I made it easy. -2, 1, 6, 13, and 22. But all your y values are your range, and you're finished. That's your domain, and that's your range. Now, look at letter B. I have one like this, I'm just telling you, either on the quiz or the test, I can't remember, but it throws people off every single year. Because you know what they try to do? They try to perform the vertical line test here. But what's the problem with that? Are those points connected in any way, shape, or form to form a graph? No, these are just 4 individual points. So we're going to identify the ordered pairs, and then we're going to pull down the domain and the range. All right, so please don't try to do the vertical line test here because it's not a graph. It's 4 individual points. Now, we're going to go back to 7th grade for just a second, and we're going to talk about how we graph points, because if we're going to identify the coordinates of those points, we have to know what they did, all right? And you're going to be graphing them on your paper because there are no points on your paper. So let's start with this point right here. When you graph a point on a coordinate plane, where do you always begin or start? Right in the what? Right in the middle. You have to start at 0, 0, which is right here in the middle. So watch what I do to get this first ordered pair. I start in the middle and I move over to the left until I am lined up with that point that I'm trying to find, which makes my x coordinate what? I went over to what on the x-axis? -2. Then I go up to what number on the y-axis? 4. So my y-coordinate is 4. And that's my first ordered pair. -2, 4. All right, now what about this point right here? Katie?
That one you go over to -1.
All right, over, help me. Over is not a direction because I need to know right or left. So
Left.
I go left. When I go left to line up with the point, I'm at -1. So my x-coordinate is -1.
And when you go up, you go up to 2.
I go up to +2, which becomes my y-coordinate. So that ordered pair is -1, 2. All right, Jordan, what about this point right here?
You go to the right 1 and do +1.
Okay.
And you go up to +2.
There we go. So we go right to 1, so my x-coordinate is 1, and then I go up to +2, so my y-coordinate is 2. Jack, can you give me the coordinates to that last point?
So you start in the middle at 0 and you go over to 2.
Over, not over, right or left?
So you go right to 2.
Right to 2.
Go up to 4.
Good. So my x-coordinate is 2. Then I go up to 4 on the y-axis, so my y-coordinate is 4. So now I have my 4 ordered pairs. So now I can go identify my domain, which are my what values? My x, and my range, which are my what? My y. All right, what is my domain, Emma? Well, that's, yes. Very good. Again, not only did she give me all of the x coordinates, but she gave them to me in numerical order. So -2, -1, 1, and 2. Actually, what is my range? 2, 2, 4, and 4. Now notice, it doesn't matter if my ranges repeat, okay? It's my domains that can't repeat if I have a function. So my ranges might repeat, but notice that my domains will not. If I'm dealing with a function, every single one of my domains, every single one of my x values will be the same. All right, letter C. Now, if you go back to example number 2 and you look at the parabola in that example, what do you notice was on the ends of that parabola? Arrows, all right? What do you notice is missing from this parabola? Arrows. Instead, this parabola has a definite starting point and a definite ending point. So I want you to plot those 2 points on the end because this is going to help us determine our domain and our range the quickest. All right, so we've got the domain. Let's go ahead and write domain down here with X and range with our Y. And let's talk about this for just a second. If my graph starts here, what is the smallest X value on this graph? This is where my graph starts. We're going to look left to right. What is the smallest then X value on this graph? -2. You say, how do you know? Because I go down here and I see that that point is lined up with -2. So I'm going to put a -2 down for my domain. I also see this point right here, which means the highest domain or the highest X value I have is a what? 3. Again, how do I know? Because I look down, it's lined up with 3 on the X axis. So I'm going to put my 3 over here. So I have a -2 and I have a 3. And what variable goes with domain? X. So right here in the center, I'm going to put an X. Because my lowest X value is -2, my highest X value is 3. So does anyone see, and imagine this is a number line for just a second. Can anybody see what we are creating with this domain? An inequality. What kind of inequality though? An and, which also is known as a compound inequality, right? We just tested over this yesterday. All right, so we have to decide if X is greater than or less than -2, and if X is less than or greater than 3. So let's treat this like a number line. If I start at -2 and I move across the graph, are my X values getting larger or smaller? They're getting larger because we're going to the right. So X is greater than -2. Question is it also or equal to? Well, look at the endpoint. Is the endpoint on the graph? Is it part of the graph? Yeah, so it is or equal to. Now, let's say I started at the 3 and I started moving across the graph. Are my X values getting larger or smaller to the left? Smaller. So X is less than. Again, less than or equal to or just less than? Less than or equal to. So my domain falls between -2 and +3. Now, again, for the range, that's our Y values, right? So we're going to take this graph, we're going to shift it up just a little bit so we don't have to deal with fractions or decimals. So this is the bottom of my graph. So what is the lowest Y value for my range? -2. And then I go all the way to the top of the graph. What's the highest Y value? Be careful. I pass the 3 right here and I go up to the next line, which definitely makes a 4. So my range, and my Y is in the center again, my range is between -2 and 4. Now I just got to figure out my symbols. All right, if I start at -2 and go up the graph, are my numbers getting larger or smaller? Larger. So Y is greater than, is it greater than or equal to? Yes. Again, -2 is part of the graph. And then if I were to start up here at the 4 and come down, are my Y's getting smaller or larger? Smaller. So Y is less than or equal to 4. Because again, 4 is the top of the graph. So this is my domain and my range. And listen, this is the most difficult domain and range that you're going to have to deal with. All right? So don't let this discourage you. Typically, the domain is just my X values and my range is just my Y values. Any questions? Now, while I do not need these arrows drawn on a quiz or a test, I don't think it's a bad idea in your notes to draw yourself those arrows so you know exactly how we figured out the domain and the range. So add those arrows if you do not have them yet on letter C. Now, the last thing we're going to do today also tends to trip people up. So let me try to make this as simple as possible. You see the word independent and you see the word dependent. Okay, let's talk about real life for just a second. In this room, there are people who are considered independent and there are people considered dependent. Do you know in this room who would be considered an independent person? Me, right? Why me? I'm an adult, right? So I can drive myself wherever I want to go. I can buy myself whatever I want to buy. All right? I can do whatever I want to do because I am independent. So there is a variable in your problems that is independent. I can put whatever number I want in place of that variable. That variable can become a 1, it can become a -5, it can become a 10, and that would be considered the independent variable. Now, you guys are very dependent, right? Who are you dependent upon? Parents, grandparents. You only can go where they drive you. You only can eat what they buy you at the store. All right, so you are very dependent upon your parents. So there's another variable in these problems that is dependent upon what happens on the other side of the problem. So the easiest way I can explain this is when you're looking at a function like the one in this example, there is one variable that has to be multiplied by -4 and has to have 14 added to it. And then sitting on the other side is a variable all by itself, waiting to see what happens on the other side, right? So an independent variable represents your input value. So it's the variable where you're going to put in different numbers. Now, there's two words right there I want you to highlight. I want you to highlight independent, and I want you to highlight input. Those two words are interchangeable. What are the other two words that we've learned in this lesson for input values? Or what are the other two? Thank you. Okay, X. So at the end of this definition, I want you to add X, and I want you to add domain. And now all four words are in one spot. And I want you to highlight X, and I want you to highlight domain. So I need you to understand, I can use the word independent variable, and I'm talking about input values. I can say input values, I'm talking about X coordinates. I can say X coordinates, and I'm talking about the domain. So do you see how those four things are interchangeable? They all represent the same thing. Now, you say, how can I remember that independent variable is my input? What do both of those words start with? Well, they start with an I or they start with N. Either way is fine. All right? Then you've got dependent. Now, highlight dependent, and in the definition it says, dependent variable represents the output value. So that means the dependent variable is my output. What are two more things I've learned that represent outputs? Y and range. So at the end, I'm going to add Y, and I'm going to add range. And this is not an option. Everybody should be adding this, and everybody should be highlighting this. Okay? So now, here we are again. There's four words that are interchangeable. If I'm asking you for the dependent variable, I'm asking you for the output. If I ask you for the output, I'm asking you for the Y values. And if I'm talking about Y values, I'm talking about the range. So there they are, all in one spot. Now, look at letter A. It says the function A equals -4b plus 14, and it represents the number A of avocados you have left after making B batches of guacamole. So number 1 says, identify the independent and the dependent variable. So we're going to write down IV for independent variable, and we're going to write down DV for dependent variable. Now here's the trick, okay? We've been talking about X and Y all day, but we aren't always guaranteed that X and Y are going to be in our function. So we've got to decide in this particular function which letter represents that X or the input and which letter represents Y or the output. So looking at that function, which variable is in the place where we're going to be able to plug any number in that we want to? Because that's going to be our independent variable, our input. So which of those variables is sitting in the spot where we can put in anything that we want to? B. Okay, remember, we already talked about how the variable that sits alone is the dependent variable because it's waiting to see what happens on the other side. Okay, the A is going to depend on what happens on the other side. So your independent variable for this problem is B. And what did B represent? It's in the problem. B represents what? Batches. So not only are we going to write down the variable, but we're always going to write down what that letter represents because we want to be real clear about what it represents. Now, do you see where B sits? We can put whatever number we want. We can make however many batches of guacamole we want, but then we're going to have to multiply by -4 and add 14. And whatever comes out on that side is what A equals. So what is our dependent variable? What's sitting there waiting to see what happens on the other side? A. So our dependent variable is our avocados. We won't know how many avocados we have left until we've decided how many batches of guacamole we want to make. So make sure not only do you write down A, but you write down what it represents, which is avocados. So there's your independent and there's your dependent. Are there any questions? Now, number 2 asks us or tells us that the domain for this problem is 0, 1, 2, and 3. So domain, are these numbers going to go in place of B or are these going to go in place of A? Again, you got to know what domain goes with. Does it go with your independent variable or your dependent variable? Your independent variable. So we are going to create a chart that has a B column for the batches of guacamole, a column that has the function A equals -4B plus 14, and of course a column that has an A for the avocados that are left. Now they have given us the domain. They have given us the B, the independent variable amounts. So 0, 1, 2, and 3. We're going to make no batches of guacamole, 1 batch, 2 batch, and then 3 batches. Now, when we plug numbers into equations, what do we plug them in? Inside of parentheses. So A equals -4 times 0 plus 14. And we're going to do that 3 more times. A equals -4 times 1 plus 14. A equals -4 times 2 plus 14. And A equals -4 times 3 plus 14. Now we're going to do the math in the middle. But be careful. We've got multiplication and addition. Which one are we supposed to do first?
Addition.
Please excuse my dear Aunt Sally. Multiplication, order of operations. So -4 times 0 is what? 0. 0 plus 14 is 14. That's my first output, my first number of avocados left. If I make no batches of guacamole, I have 14 avocados left. All right, what's -4 times 1? -4 plus 14. 10. So if I make 1 batch of guacamole, I have 10 avocados left. All right, number 2. 2 batches. -4 times 2 is what?
8.
And -8 plus 14? 6. So if I make 2 batches of guacamole, I have 6 avocados left. And what's -4 times 3?
-12.
And -12 plus 14? -2. So if I make 3 batches of guacamole, I only have 2 avocados left. Now, notice that final column, and let me try to help you. If our domain are numbers that are in order, so we've got 0, 1, 2, and 3, then our output should also be in a pattern. Do you see the pattern over there? What happens each time we make a batch of guacamole? We drop how many avocados? 4. So if for some reason you end up over there with a 14, a 10, a 6, and a -2, that should trigger you to know I did something wrong because the pattern is not there. All right? So just keep that in mind. That's an extra way to check and make sure you have that final column correct. But we're not quite done because it says, what is the range? Now, the range is the same thing as what? The dependent variable, which is A. So what is the range of this problem?
14.
Careful.
Oh, 2, 6.
2, 6, 10, and 14. We still want our range in order from least to greatest. And that is lesson 3.1.